Hello. Hello. Hello, Michelle. Hello, Cheska. Hello, Melita. Hello. Good to see you three. What's up, Chris? Um, what is up? Good afternoon, Yavi. She's like, great to see the sky. Well, yes. Although these days it almost seems like it's falling down. But yes, good afternoon. How are you? Um, good afternoon, Matthew. Awesome. Wait, Melita's smiling. That's pretty awesome. Or was. Okay. Sorry. Oh, wait, sorry. Okay. I don't mean to call it wrong. Oh, it's the ceiling. Wow. Oh, that's what you were smiling. It's the ceiling. Okay. Actually, when we get to anyways, good afternoon. Yes. Thank you. See, other people have tuned into, well, no, I won't even say this. Okay. I know we spent so long saying hello that it's like the moon. Well, okay, right. Actually, remind me when we get to physics 204, you'll find out that one answer to what's up is north cross west. When we get to cross products of vectors. But anyway, good afternoon, Marilyn. If I didn't say that, I'm sorry. But yes, great to see Michelle, great to see Cheska, great to see Melita, great to see Chris. Great to hear. It was great to see Amanda. Oh, wait, do we have a majority of video? Well, if you count me, we almost have half. This is amazing. If like one more person shows video, we might set a sounds like a card. That's funny. I don't even get that, but that's funny. Hi, you. Oh my God, she totally did it. That's great. We lit that. You might have just set the new, even in pre-COVID. I mean, even I think you guys just set the record for the greatest percentage of videos, even for 1 minute. So, like, thank you. Wow, that's amazing. Hayu, don't forget to submit for points. Wait, are Hayu and Amanda in the same place? Wait, are you guys? You are cool. That's wild. Okay. All right, I'll stop calling. Oh, and Yavi. Oh my God. I better make today's class worth it. I'm actually. Oh, weird. Whoa, no way. Okay, that's very cool. Well, that works. And I got to give credit to you also, by the way. Just if you're not, wait, okay, well, that's great. Why not? Let's go. Yes, let's go. Oh my God, I love that expression. I still remember. Okay, yes, let's go. Absolutely. Um, this is good too. I'm glad if that means that you guys actually ever hang out with each other and you ever even, that's great. I mean, great. All right, I won't over talk about it, but that's terrific that you're together. You guys should all visit me on a Tuesday in my office. Anyway, you should say. Well, okay, Amanda, I'm going to go with Amanda's thing. Chris is always the one that celebrates by canceling class, and now Amanda's celebrating. Well, you're not going to. It is true. Let's go. Oh my God. I love that expression. I didn't understand it when I first heard it, but okay, we are gonna go. We do have to. I'll tell you too. I'm like totally sick. I can't believe how much energy you guys just. I've never. If you happen to. The last class today, the 12:15 class, I was lower energy than I think I've ever been. I mean, it was like I was almost a normal person just because I'm like so sick and tired. It was almost, but and you guys have just fired me up. I don't know what to say. You're totally firing me up. We're gonna get going. Wow, it's like almost all video. Holy, oh my God! I should open up a portal for if even for 1 minute we were 100%. I should do that. I'll open up a portal that if somehow, especially since you're all together, since a lot of you are together, so you can like do the peer pressure thing or whatever, or you're doing it already. We should have like a bajillion points if somehow a class manages to go 100%, even for a minute. Well, whoa, interesting. Wait, oh my God, we're into the birthdays and everything now. Okay. By the way, I will admit I am a Scorpio actually, but let's not go down that road. Wait, okay. You're gonna if you're see this class is very clever. You're gonna get me off the topic for an hour and 15 minutes. It could happen. Okay, wait. I will say that if ever there's even a minute, I mean, even a moment where there's 100% video, that would definitely, like, I should definitely open up a portal for that. That's a wild idea. But second of all, as far as homework, actually, Amanda and Chris you're not getting new homework for a little, like, I don't want to get into all this right now, but no, you're not going to get another homework for a while. We all have to catch up. Like many of you still have to make an attempt at homework 7. I have not nearly finished going through homework 6. So you're not getting another homework for a while. Now, I don't want to burst the bubble here and change the mood. But full disclosure, excuse me, I am sick right now. So we're not gonna have a tense negotiation or a hard talk. Excuse me. Someday, I mean, this is the one thing. Everything goes through Zoom except for like smell, like all the 5 cents. Like, it's weird that I don't have to cover my mouth. I mean, I do. It's still gross, but all right. Anyway, I'm so distracted. Look, I have to say one piece of bad news. People have asked me, or someone asked me in the other class, like, of course we have to have an exam at some point. We do have to have a midterm exam. I don't want to get all into that right now. I can just tell you or just remind you that I never surprise you with an exam. That's not going to happen. When you have an exam, you always have at least a week of preparation and notice and stuff like that with a practice exam. Like, we always have a practice document that doesn't count for anything, but shows you what the exam will look like. It's not just a study guide. It's literally, I've mentioned this before. You'll see basically a rough draft of the exam, like at least a week before the actual exam. We will talk about it. You might even have a review session in lab where you go over solutions to the practice. That I can't promise, but that often happens. You won't just sneak up on you, but I will say we are getting close to that point where we have to start. So just for planning purposes, you should start assuming that like 2 weeks from now, 2 weeks from today or thereabouts, is probably when we'll have some kind of exam experience. But let me also say, so you can mark your calendars if you want for 2 Wednesdays from today, but also that's not even a firm thing, because number one, I might have mentioned before, when we have an exam in this class, it's take home anyway. So if I say we have an exam in 2 Wednesdays from now, that probably means that's when it's posted, and then it's due back a few days after that. Okay, they're take home, they are not timed. Okay, that's number one. Number two, it probably will be 2 weeks from today, but I don't feel like having this whole class period talking about it right now. So I'll also say that, like, this coming Monday or something, I'm going to do a check-in with you and make sure that you don't all have an orgo exam or something that day. Like, there'll be a moment where you can give me input if that's a crazy bad day or something like that. So just bear it in mind. I don't want to spend today talking about it. I don't like talking about exams any more than you do. But if you're trying to plan your life, you can start assuming that like 2 weeks from today is some kind of exam day. Unless it turns out that you all tell me that there's like orgo or PChem or something that day. Okay. So I'm just getting, why I'm even bringing that up is not to burst the mood bubble, but because a couple of people made jokes. Oh, thank you. I totally appreciate it. Oh yeah, no, thank you. No, I definitely do try to not compete with orgo or something. Yes, I will find out from you. I mean, thank you for saying so in the direct chat, but yeah. But the other thing is, about that, why I'm even bringing it up now, well, partly because, you should know when someone asks, but also, like, the last thing that you would be responsible for on that exam would be homework 7. I doubt you're going to get any more homework between now and the time you have the exam. If you did get more homework, it wouldn't be part of that exam. So if you're trying to plan or get your mind around things, the homework would, it'd be up through homework 7 at most. Okay, just all right. Now, okay. Story of your life as a STEM student. Right. Okay, drink liquids. Yes, I'm trying. The question, the big science question these days is, does Celsius count as a liquid? I'm not sure. I had way too many of those Celsiuses this week. And if you have like 2 Celsiuses in a week, you know how many that is in Fahrenheit? Just kidding. Okay. All right. So thank you all for being, again, so good and responsible at watching the video and giving me feedback. There's a couple of people who watched the video whose feedback I haven't given back to them yet, but most of you, I saw what you said about the video. So that's good. That helps me with the teaching, like I know what people are confused about and what they're not for most of you. If you still haven't seen the video from yesterday, please do. It's not too late. It would still be very worth it. But today, okay. Right. So you saw the video. That was yesterday. Thank you. Right. That next time that happens, it'll happen to the other class section. What I'm trying to say is we're still talking about homework 6. Okay. We're still in the middle in classes of going over homework 6. Homework 6 is still technically about one-dimensional kinematics. Oh, let me get this thing going here. And equations like the one on the board. I still have to, at some point,
momentarily stop and just give you a list of all the equations I think we have so far. I'll do that. And certainly you'll get that for the exam and everything. But what I'm trying to say is in homework 6, there are really 2 threads. There are 2 themes running through homework 6, just to be clear. One theme is the relational character of velocities, the relative nature of velocities, the idea that velocity is a relation, not it's a relation between 2 objects. It's not a property of one. Or put another way, Galileo's principle of relativity is one theme that we've been talking about for days and starts becoming important in homework 6 and is hugely important in homework 7. Okay, I'm just summarizing something now since we didn't have class yesterday. So one theme is this Galileo's principle of relativity that's never going to go away, that is always going to be part of our life in physics, no matter like what we're doing. It's a thread that runs through all topics, okay? So we've been talking about it, and the video yesterday was about it, and I know some of you are still concerned about it. Fair enough, because it never goes away. So you never master the Galileo principle of relativity. So when some of you are asking in your video feedback stuff like, I need to see more concrete examples, I'm still not really clear how it's applied, totally understand. And we will do more concrete examples and we will keep talking about it. And I will answer more direct questions about it. But I want to say that's one theme that's going through homework 6. The other theme that's going through homework 6 is just constant acceleration in general and the constant acceleration equations. So there's basically velocities going on and the whole issue of how velocity is a relation between 2 objects, not a property of one. And then there's the issue of changes of velocity, acceleration, and the equations that come from that. To be clear, yesterday's video and last week's class were all about the first thing, about Galileo and relativity. Whether you're confused about that or not, I want to make clear that today we're not talking about that. We're going back to sort of the basics of homework 6. Okay, today we're going to be dealing more with like this equation that's at the front, at the top of the board, and possibly the one underneath it. So in theory, today we're picking up where I left off in the video yesterday, which is in theory. I'll screenshot it right. In theory. Let me just do a quick, screen share, just so you know exactly. Because we didn't meet yesterday, I just want to be clear where we are. Okay, sorry. Hold on. Yeah, I'm just going to change the screen for a second. Wait, you can hear me, right? Yeah, of course you, okay. Otherwise, all the jokes wouldn't make any sense. Okay. Just so you know, even though yesterday's video was a lot about relative velocity and all that, where I left off at the end of yesterday's video class was the first column, the first row of this table right here in this problem, velocity time graph. Okay, so this problem, all the data or all the facts are all being measured from the reference frame of Earth or from the reference frame of the lab. And there's only one object being watched from the lab here. Like, okay, so I'm partly answering a question that was being asked by the videos. Like here in this case, we have Edna is one object and we're watching from the lab or watching from Earth. So lab or Earth would be another object. So we've got like we've got object A. We could call Edna object A if you like. We could call Earth or the lab object B if you like. Like someone was asking me in the videos, like, how do you know what to call what? Well, the answer is you make whatever decision you want. A, B, and C just stand for any 3 objects. The whole point is that one object is not any more special than another. Like the point of all this, all perspectives are equally valid as long as they're unaccelerated. So you could call Earth object A and you could call Edna object B or something. That'd be perfectly fine. And you call whatever you want, and then you have to just stay consistent with that. But in this problem here, there's no third object. There isn't any third object. It's just Edna being watched in planet Earth or in the lab. So all the issues of relation in A to B and B to C and C, all those issues are not part of this problem. I just want to make that clear because we're getting used to all these different issues. This is just like the straight up constant acceleration equations and stuff like that. So this is where we left off yesterday. And what I decided to do today, what we're going to do right now, I'm going to change the screen again. I'm going off page here. Like if you look at row 1, I just made up a practice problem this morning that I want, there's like a do now that everybody, so I'm going to switch screens again. And this is what we did this morning. I'm going to give you a practice problem right now that's just based. It's like zooming in on this chart and what this chart is all about. So it's a practice problem. Here, I'm changing the screen again. Sorry. Okay. Yeah. So we have this. It's going to come on the screen in a second. Yeah. Hello, go. Yeah. Okay. So we have like this warm up, a do now problem that I'm giving to you. It's written on the board here. Some of you will find it easy. Some of it you will find it hard. I mean, this is part 1 of it. It has other parts on the next page. Some of you are going to find it easy. Some of you are going to find it hard. Some of you are going to find it easy, but you're easily going to get the wrong answer. I mean, just to warn you, like some of you might find it so easy, too easy because you're actually not doing it right. Whatever. What's going to happen is if you could screenshot this, please, or copy it down because there's more pages to this. What I'm going to ask all of you to do, so this is like to get us back together and to practice and to actually figure out what's going on in these homework sheets. You're going to solve this now, like on your side, on your paper. And those of you who are all sitting together at John Jay, I'm perfectly happy if you work together on this. That is fine. That's great. And no one's getting a grade on this or anything. So it's not like they're cheat. Those people who are, don't be jealous of the people that are all sitting at a table together. Like, I think it's a fine thing. If they want to help each other, Quark bless America, they should. But no matter what you do, you're going to put your answers or questions or concerns all in direct chat, no public chat for this, okay? So you screenshot this. There's going to be more to the question. You'll see in a second. Work at your own pace. And what we're going to do is like, so it's going to be sort of a quieter class, but you start putting answers or confusions in the direct chat. I will answer in direct chat. So I'm just going to be typing away back. So just be patient with me. I'm just going to go through the direct chat. And once I've responded at least once to every person in the direct chat, then I'll stop and I'll go over it. Okay. I mean, obviously in some people's cases, I will end up responding more than once but I will make sure you understand what I'm saying. So I'm just going to go. So this is a scenario. A rock is dropped. It's for practice. A rock is dropped from rest. It's dropped near the surface of the earth. So so it's not a trick. It's dropped. It's not thrust or thrown. It's dropped from rest. Any fact that you believe you already know about free fall acceleration or the constant acceleration due to free fall, you need to use that fact. In fact, I don't want to play hide the ball. Like if you think that the number 9.8 meters per second squared is somehow relevant to this problem, you are correct. And yes, I'm expecting people to start to rely on that number. You totally can and should use that number for this problem, but I'll also caution you right now. The whole problem will be a better experience for you. Again, there's more to it than just this first page. The whole problem and the discussion will be a better experience for everybody if you start getting in the habit of doing what all physicists do when they're not inside a lab, and that is round the number 9.8 to 10. You're not cheating. You're not lying. You're not being a bad scientist. Everybody does it. You got to realize that 9.8 in the first place was already rounded. So the actual number has an infinite set of digits that go on forever without pattern or repeat. So if we're going to chop off digits, we might as well chop off one more and make it much easier to picture all this in our head and much easier to do. So if you're going to use the number 9 anywhere, I encourage you right now to round it to 10. I also encourage you, since at this point in the problem, everything goes down, nothing goes up. So I encourage you to think of down as positive. There's no point in introducing negative signs when you don't need to. Okay, so the first exercise you're just going to do, it just says, it's not a trick. If you drop something from rest near the surface of the earth, how far does it fall in 1 second? That's not a trick, but it is may be trickier than it sounds. Like some people think the answer is super obvious to that. I don't know if it's as super obvious as you might think. You have to work it through. But then I'm going to say now here, so hopefully you screenshotted that, or I can go back because there's more to this now. Like that's question one. But then A says, if you try to solve this in more than one way, like you could put an answer in the chat if you want to check the answer. But if you got that answer by just plugging into a certain equation, especially say an equation that has squares in it or something, then try to back up and see if you can do it another way. See if you can actually make sense of this problem and actually picture in your head or use some logic or use other equations. If you've used one, see if there's any other. There's more than one way to solve this. And the more ways that you can see the same answer, the more you really know it. If you think it's really hard, then just try to do one way. But if you think it's a quick, easy thing, then try to do more than one way. So that's number one. So you're going to try to get that answer. You're going to try to do it more than one way. And I'm going to talk about it when I go over it in more than one way. Then part B is then same concept, but now I want to know how far it's fallen in 5 seconds. Now here, I'm really going to say, really here, once you think you've gotten the right answer to the first one, we're just taking the same problem and just making it slightly harder. So I'm going to say here, wait, how do I'm going to say here. Wait, how do sorry. I forget how to, I got what's going on here. Sorry. How do I, oh, okay. Here, you must solve a different way. Like the point of B is to really see that you realized something in A. So however you got the answer to A, I want you to get the answer to B some different way. For example, it says in C, make a chart like the Edna chart in the other homework problem. This is just like that, okay? You can make a chart to show how to get this answer for t equals 5. The real goal, what I'm really trying to say, again, some of you will think, maybe some of you have already finished this before I've even finished talking. That is fine. But what I'm really trying, and some of you haven't though, or won't. This is just definitely one of those beats in physics where it either makes sense or it doesn't until it does. So half of us, this doesn't make sense to yet. And some of us, maybe it does. And that is okay. But if you're, I mean, that's great. But if you're one of those people that thinks you can get the answers to this really fast, what I really want to encourage you is really try to see how the answers make sense without plugging in to t squareds. Like if you only can get these right, but by plugging into t squared, then you're not really at the level we ultimately want to be at. Some people still don't know how to plug into the t squared. That's fine too. But all right, you get my point. So then finally, the last question, and again, hopefully you're screenshotting this or I can go back. But the last question is, now, say we throw the rock up at 50 meters per second. I want to know how high this rock gets. What it's, oh, sorry, there's, don't, all right, I'm going to change it because that's an answer that doesn't belong there. Oh my God. Well, am I going to change this? Yeah, I'll change it to 60. Excuse me. Okay, so the question is, if it's thrown up at 60 meters per second, how high does it get before it starts falling down again? Now here, especially here, I think this is a slightly more challenging problem than the one before it. But here too, there was one person in the other class who had some equation for this that they got off the web. Like not, it was an equation that was correct, but it was definitely not an equation that we've ever said in class. And you definitely don't want to do that. If it were an exam, I can't say it's illegal to use an equation that, but if you're using an equation that never got developed in this class, then you definitely have to explain it and explain why it's right and where it came from. Like okay, so on this one, what I'm really encouraging is, can you get this one by breaking it down into logic and not just plugging and chugging something that seems magical. All right, and I'm talking way too much. Sorry, because this class gets me far. So go, like, if you want me to turn back to any page, but that's it. Those are the questions. If you want me to turn back to the original page or whatever, I'm happy to. But again, don't put anything in the public chat, please. Just go in private chat. And if you're working as a group, that's fine too. But maybe take turns of who's putting things in the chat so I can like see participation from different people. But all right, so I'm gonna shut up. Oh, and are we in the chat? What's going on?
Can you turn to the second page, please?
Oh, the second, yeah, like this one. Okay, great, thanks. Okay, so people are already okay. Oh wait, oh bless you. Like I saw bless you in the chat. I was like, that's so nice. Thank you. I accept your blessing. But you mean because I sneezed, right? Okay. All right. So people are already in the chat. I'm going to shut up now. I really am. Oh, sorry. The question. Sorry. Okay, one sec. Sorry. And remember, everybody, if I say that you got the first one right, which is great, then you want to try to do it another way, or either right then at that moment or later on after you've done the other questions. But you want to be able to try to do it more than one way. But yes, okay. Bless me again. All right, thank you. Oh, I think I'm responding to the same person twice. Sorry, if I responded to you twice, any of you, that's a mistake. Sorry. Oh, wait. Oh, sorry. Okay, I'm talking to myself. I'm sorry.
Okay, morning. I'm still answering the chats. I think there's still some people that I haven't answered at least once to. Once I've answered once to everybody, we're gonna start talking, but we're about to be interrupted by you know who, by the Pokemon trainer himself, who will someday behave, and then I'll miss this stage. Oh, there he is. But, my God. Hello. Hello. Good. Okay. Okay. Hello. Good to see you. Okay. All right. Good to see you. So they're okay. I'll see you very soon. And we'll go. Okay. Okay.
Hi,
Yeah.
Felix.
Okay. It sounds very nice.
Whoever
Okay.
said that, you get 100 points on your next math test.
Right. It's physics. Okay. It's- okay.
No, and the math
All
test.
right. That's cool. Does that mean you got 100 today?
I never turned in my homework.
What? Or we're gonna talk about that upstairs. All right. Okay. Okay.
Skip my homework.
Wait,
Okay.
if he didn't turn in his homework, do I not have to turn in my homework?
No, wait, bad talk.
You
No,
don't, you don't have to do your homework.
okay.
I'm his son. I'm
Hey.
going to tell you what to do. No homework for the rest of the year or the
Okay,
semester.
out,
Not for the rest of your college
Okay.
or high school. It's the same
This is
as
college. All right,
said so
this is
too.
college. Okay, go ahead. Take the dog. Take the dog.
No homework. for
All right,
the
all
rest
right,
of
all
the
right.
semester.
Yeah. Oh my God. Okay. Right. Okay. Yes. If you want to end up with a job like, okay. Anyway. Right. Well, that was. Go. Okay. Yes. Okay. Right. You can see I'm as effective with disciplining him as I am with you, or vice versa. Okay. Back in the chat here. But thank you for indulging him. Thank you for being so kind to him. Thank you for not emotionally scarring him yet. Let's okay. All right. I'm just looking back at the chat. But there's a lot of good stuff in the chat. And if you're just hanging, if you think you're done and you're well, don't forget the last question, I think is not a joke, but if you're hanging out, that's cool. I'll be done. I mean, I think this question is definitely not a joke, but okay. Thank you for the blessings. Um, okay. Okay. Oh. Ah. Kind of suspicious that that whole group who's at one table is all gone now, but okay, whatever. Kind of sus. Oh, what? Oh, they came. Okay, good job, Cheska. Oh, wow. Whoa. Okay, this is like, yeah. Okay, it's like, yeah. Oh, okay, okay, all right. So basically, what are they all called? What are all the people that are not the imposter and imposter called again? What? It's imposter and a bunch of suspects? No. What are they? Anyway, what are
It's crewmate.
crewmates? Right, right. Crewmates. You're all the crewmates. Right, right. Okay. Yes.
You play
Okay.
Among Us?
Of course not. I have no idea what you're talking about. Why would I do? No, of course. Yeah, I think it's a great game. I mean, I haven't played it in a while, but I mean, have you met the guy that you just met? Like, what do you think I do with it? What am I supposed to do with him all day? Of course. But no, all right. No, but really what I really play, we'll talk about this another time. Well, no, we'll talk about it another time. Okay. Wait. So, okay. Soon I'm gonna stop. I think I can't respond to every single thing. As we'll just keep going. But as soon as I've said at least one thing to everybody, I'm gonna stop, and we might almost be there. Oh, yes, Amanda's right. Yes, it's all about Pokemon. That is correct. Oh, here we go. Speaking of which, wait, okay. Okay.
I bet.
Wait, I have to teach. What's that?
You left the car.
Which car?
The new
What,
one.
what are you doing? Oh, yeah. Okay, 1 second. Yeah. Hold on. Wait, stop. Wait, very limited time.
I am the teacher.
No,
now.
stop.
Still, no homework.
No, okay, enough.
Mm.
All right, it's on. Okay, now it's pushing luck. Okay, and I'm almost done. I'm just responding. Okay.
Show my dad
No, no,
happy
enough,
dancing.
enough, no, no,
cat
enough, enough. No dancing.
Okay, 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 all right. Ugh, I hate the dancing cat meme. That thing drives me crazy. Okay, thank you. You're very kind. Okay, Poga. Yeah, we should let him see. Now he'd probably be more efficient, that's for sure. Okay. Oh my God. All right, Felix. Okay, thank you. That's very. Now you guys are just okay. Oh, someone went back to the question. Thank you. Okay. Oh, I noticed all that's in the public chat. That's funny.
Oh no, the dog. Wait, guys. Wait, the dog just went out. Wait.
Okay. Can you believe? Oh, okay, okay. I'm gonna say yes, very sus, all sus. All right. I think because the chat is now all about imposter and Pokemon, we should play Among Us. Yeah, that's funny. Pro could. Oh my God. All right, I'm looking at the chat. I think it's a dog. Yes, yes, the dog. We got yes. Thank you, thank you. See, someone here actually is concerned about the dog. Thank you, Michelle. That's good. Okay. Okay, there are some physics things in the chat that, yeah, well, everybody's hiding from, okay. The chat is very funny. There are some physics things in the chat that I didn't get to, but I think I responded at least once to everybody. If I did not, then I apologize. Wait, did I? Because I know we only have 20 minutes left, so I should start talking about this. All right, hold on. There's one person that maybe I did not respond. But this is good, what's happening in the chat. And people's answers are developing, which I know this is like a weird way to do class, but actually I think it's to occasionally do this, I think is super helpful for me to see what you're individually really thinking. Okay. 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 Sorry, I'm starting to lose it. Okay. What we're going to do, we've 20 minutes. So this is great what you did in the chat. And a lot of the answers changed and developed, which is good. What I think I'm going to do, first, I'm just going to say the answers. But then I want to talk about them. All right. So okay, yes, in the first one. Oh my God. Here, sorry. Let me just. Okay. For the first one, what's given for question one? What's given is that the initial velocity is 0 meters per second. And what's also given is if this is free fall, right? This is free fall. What that means to me for all time, to any physicist, what free fall means is that acceleration is a constant. It doesn't change. And what that acceleration is the acceleration due to gravitational free fall. And what we generally approximate that to, well, you could say it's 9.8 meters per second squared, but what I'm encouraging all of you to do in any context other than strict measurements in the lab, if you're outside the lab, all physicists round that 9.8 to 10, okay? And we're calling down positive. So for the first question, at t equals 1, what is x? Yes, I agree that the answer, like how far
when something's free falling from rest, it free falls at a rate of acceleration of 10 meters per second squared. What I want to make clear first and foremost is if something's falling at a constant acceleration rate of 10 meters per second squared, it will not fall 10 meters in the first second. Like people tend to think that it will. It sounds like that's what that gravity number means, but that's not what that gravity number means. In the first second of free fall, an object will fall 5 meters, not 10. Now, I guess I said I was going to give all the, yeah, let me, what time is it? Yeah, I'm going to go back on my, let me talk about this before I give the other answers. The answer is 5. But I want to back up and yes, how did a lot of you get this answer? Sure. The way a lot of you got this answer was you said X, E, you plugged in. A lot of you did something like this. Like this is technically the equation. You said the initial place that it fell from, you called 0. You said its initial velocity was given as 0 because it was dropped from rest. So what a lot of you did, and I'm not saying this is wrong, but I just want to be clear about it. What a lot of you did was you plugged it and said, okay, X equals 1/2 AT squared. So 1/2 10 times 1 squared. And so you got that X equals 5. Now that is correct, but I want to back up for a second. Because the thing is that there was a lot of people who didn't plug into the equation and you just like thought about it. It was like, well, if it's falling at a rate of 10 meters per second squared, I mean, doesn't that seem like logically it sounds like it's saying, I mean, it's falling. Doesn't that mean like every second it's gaining 10 meters per second of speed? So if it's going 10 meters per second, at the end of the first second, doesn't that mean it falls 10 meters? So a lot of you were like using some kind of logic, like if you couldn't remember the equation or you didn't like the equation, whatever, you were using some sort of logic, but the logic led you to saying 10 rather than the correct answer, which is 5. But here's the thing. The reason I'm not just stopping there, or the reason I asked a lot of you in the chat, now do it a different way or something, is because if I don't want to use equations instead of logic. I mean, that's where we get into trouble. And that's when physics becomes unnecessarily hard in the wrong way. I don't want to say to you guys, well, it seems like it would be logical that it would fall 10 meters, but don't even think about logic. Forget logic. Don't trust your basic thoughts about this. Just plug in the equation and trust it and let's move on. Like that, no. Like, because then you have no, if the equation's saying something that doesn't seem logical, then you don't have a reason to trust it. And if you just plug and chug blindly in the equation, you're going to end up in that same jam that people often are in physics, which is when the problems get really hard, you won't know which equation to use. You won't know how to choose which equation because you're just trusting them blindly, right? And you won't be able to double check your answers or have any, what I'm saying, we don't want to just plug into equations blindly, especially if the equation seems to go against something that seems logical. I'm here to say physics is supposed to be logical. It is all supposed to make sense in the end. The equations are meant to reflect sense, not get rid of it. So the people in the room, that in the Zoom room, that used sense to come up with 10, like, okay, 10 is the wrong answer, but it's not wrong just because the equation says so. The people that did the equation have a duty or a job to make sure that the equation actually makes sense to them. So that's what I want to show you now. That's why I was asking you, can you think about it in a different way? And make it clear why the first object, the first second of free fall, an object doesn't fall a full 10 meters. It only falls 5. Here's why. The reason is what that 10 number means. What the gravitational 10 number means is that every second we gain 10 meters per second of velocity, not 10 meters of distance, but 10 meters per second of velocity. In other words, oh, I forgot I already had a board for this. That's okay. Well, I already explained this in the, well, whatever, at the end of at the end of the first second, in other words, at t equals 1 second, instantaneous v at t equals 1 equals 10 meters per second, right? And how do I know that? The definition of average acceleration is change in velocity per time. Whoops. So I can rearrange that, right? I'm just multiplying both sides by t and adding v naught to both sides. V naught is 0, right? So v equals 10. I'm saying, what I'm trying to say right here is, and I'm not done, and I should have used the other. What I'm saying right here is, what does 10 mean? It means at the end of the first second, the final velocity at that moment is 10 meters per second. Still, you might think, well, then, okay, doesn't it travel 10 meters? I mean, it's 10 meters per second for 1 second. Doesn't that make 10 meters? No, because it wasn't traveling 10 meters per second that whole time. In fact, during that whole 1 second, it wasn't traveling 10 meters per second. In fact, it was never traveling 10 meters per second until the very final instant. It was always going something slower than 10 meters per second. It was building up speed steadily for the entire 1 second until at the last moment of that second, it got to 10 meters per second. So we can't believe that the thing, it wasn't equivalent to some car or some other ball constantly going 10 meters per second for a second. If something went constantly 10 meters per second for a second, or even if it went on average 10 meters per second for a second, then it would travel 10 meters. In other words, what I'm saying is our original definition of average velocity is displacement per time. The amount of displacement that something undergoes in a certain amount of time is its average velocity times time. It's average velocity, not its final instantaneous velocity. How fast on average it's going is times time, is how far you go, right? So we want to know how far this thing went in 1 second without plugging into equations that we don't mean anything. And we want to know, what we can say is the farthest that this thing fell was its average velocity times 1 second. And the question is, what is its average velocity? Well, since acceleration is constant, we can solve for average velocity. We can solve for the average velocity and say that the average velocity is the average of the lowest velocity and the highest velocity. This goes back to that whole averaging thing. Like, what average velocity means is displacement per time. But in the case of constant acceleration, we can say that the average velocity is that middle velocity between the two extremes. The average velocity here would be 0 plus the final velocity, all divided by 2. In other words, I'm saying that this rock that we dropped, like, even if I don't plug into equations, if I just think about it logically, this rock accelerated from a speed of 0, smoothly, constantly, until it got to a speed of 10. At the beginning, it was going 0. At the end, it was going 10. It was always going something faster than 0. It was always going something slower than 10. On average, what it was doing on average was going the middle number between those two, was going 5 on average. So what we have here is the equivalent of a rock. We have the equivalent of a car driving constantly at 5 miles per hour for a full hour. We have here, I'm saying that X here equals 5 meters per second times 1 second. That's why X equals 5 meters. Do you see what I'm saying? And well, do you see what I'm saying? Like, it actually makes sense. It does make sense that it only falls 5 meters in the first second. Because on average, it was always only going 5 meters per second. If you went to the third second, well, yeah, okay. And for example, in the next second, it goes the average velocity for that next 1 second. What's the average for the next one? I'm just making it. For the next one, it's the average of 10 plus 20 divided by 2 times 1. In other words, in the next second, it will travel 15 meters. And if you keep going like that, I mean, I'll go back to the problem in a second, but in the first second, it travels 5. In the next second, it travels 15. Why did I get 15? Because it's speeding up now from 10 to 20. Then in the next second, it's speeding up from 20 to 30. So it goes 25. I'm saying I think you get what I'm saying. I'm saying that your equation, the equation that you plugged into, the equation that many of you plugged into right here on the board, that looks just like random, like 1/2 AT squared, and many of us are just randomly plugging in. Where did it come from? It came from doing the process that I just broke down. It came from going, well, the distance something traveled would be its average velocity times its time, would be average velocity times time. The average we get by taking the first and the last and adding them together and dividing by 2. So that's where that 1/2 comes in. The reason you do 1/2 AT squared, you're really saying it's half of the final plus the initial. It's the final plus the initial velocities divided by 2, because we're averaging. So the average velocity times the time is what's giving us the displacement. And what's the average? The average is the average of the first velocity and the final velocity. Where did we get the final velocity from? It is acceleration times time. So time comes into this twice. You have to, the whole displacement is the average velocity times the time. The average velocity is the average of the initial and the final. And the final, where did we get it? We got it by saying, oh, every second you gain 10 meters per second of velocity. So the final is acceleration times time. So it's acceleration times time plus initial divided by 2 times time. That's why the time gets squared. That's why the 1/2 comes in. What you're really doing is taking into account the average velocity. Excuse me. Okay, so the answer is 5 to that. If we go to the next one, again, the next question, I know we have 4 minutes left. Sorry. The next one, as many of you put in the chat, yes, the answer to the next one is 125 meters. And yes, you can get that by plugging in. But again, you'll really know that you really understand the 125 if you can think of it without just plugging in. The way I think of it, I think I have a chart in my head, in effect. Well, the way I think of it is, if it's 5 seconds, that means at the end, at t equals 5, the final velocity will be 50, right? Like every second, I'm gaining 10 meters per second of velocity. So at the end of 5 seconds, my final velocity is 50 meters per second, which a lot of you put in the chat. That's my final velocity. But if the question is asking how far I got, what do I do with that? I don't say 50 times. I don't say that I'm going 50 meters per second times 5 seconds. I don't say 50 times 5 and get 250. I say I'm going 50 meters per second at the end. So on average, I'm going 0 plus 50 divided by 2. I'm going on average 25 meters per second. That's what I'm doing on average, and I do it for 5 seconds. So 25 times 5 is 125. That's what I'm thinking in my head. And like, that's the same thing as plugging in the formula, the equation. But to me, that captures the logic of what's going on. The logic of what's going on is we're still believing always that displacement equals average velocity times time. And the way we're getting average velocity now is we're literally averaging the lowest with the highest and dividing by 2. We can do that as long as acceleration is a constant. So then, to get the, since we only have 2 more minutes, to get the final answer of the final question, where I said, in the final answer, last one, we have 1.5 minutes. Final question. If you throw it up at v equals 60 meters per second, and we want to know how high it gets, here's how I do it. Like, you could plug into the equations, but here's how how high does it get? Here's what I think. I think, well, first of all, if you're throwing it up at 60, in my head, I right away say, well, it's going to be traveling for 6 seconds. 6 seconds. Where did I get that? Because it's losing 10 meters per second every second, right? The acceleration is still 10 pointing down, always 10 pointing down meters per second squared, but we're throwing it up. So it's getting slower and slower by 10 every second. When it stops, when it reaches a peak height, that's when its final velocity will be 0, right? So equation wise, what I'm doing, where did I get? So I'm saying, we have 1 minute left. I'm saying the time it'll take to get to the top is 6 seconds. If you want to see that in an equation, technically what I'm doing is saying this. And I'm setting the final velocity to 0, and I'm multiplying both sides by t. So t equals negative v naught over a. So that means negative 60 over negative 10. So 6 seconds. So it's going to go up for 6 seconds. That's the amount of time it would take to run out of speed entirely. Okay, we're just about done. But what speed is it going on average for those 6 seconds? On average, I think it's going 60 plus 0 divided by 2. It's going 30 meters per second. So I think, how high is this thing going to get? 6 times 30, 180 meters. That's what I think the answer is to the last one. And if you plugged into the equation properly, you probably got that, I guess, but you have to be careful about your negative signs and stuff like that. I think that's the answer. And just the whole point is that it all reduces in the end to what we started the whole semester with. We still believe average velocity equals displacement over time. That's the class. You've been very, very patient. We'll get back to the actual homework 6 on Monday, and then we'll keep, but no more new homework. Just play a lot of Pokemon, particularly Scarlet and Violet. And root for Meowscarada. Okay, and I'll hang out if there's any questions at all. Yeah, I'll hang out, but thank you. And Among Us, yes, and play a lot of Among Us. Right. And don't be sus. Yes, don't be sus. Okay, thank you guys very much. I'm glad you guys work together. That's great. I'll bring back Felix. Thank you. Please, we have enough. All right, thank you guys. Yes, awesome. 360 no scope. That's all I can say. Okay, bye. Have it. Bye. Okay, and I'm topping the record. If anybody has questions, I'm here.